Hey guys, so today I'll be starting topic 10, which is called solving rational equations. Okay, so we're going to keep working with fractions and variables, but now we're going to move on to rational equations rather than expressions. Okay, so let me get started with some notes. Okay. So what is a rational equation? So a rational equation is an equation that contains at least one rational expression, which is what we have been working with in topic 9. The difference between a rational equation and a rational expression is that an equation has an equal sign. Okay, so if you don't see an equal sign, then that's a rational expression. If you see an equal sign, that's a rational equation. So pretty easy to remember because the word equation pretty much has equal in it. So when you solve a rational equation, you are basically looking for the value of the variable that will make both sides equal. So it's just like solving a regular equation. When we solve a regular equation, let's say the equation has x's in it. We're looking for the x value that'll make both sides of the equation equal or the same. Okay? But because we have because we have fractions, solving a rational equation is a little bit harder than solving a regular equation because we have to eliminate the fractional pieces first. And the way we do that is the way we've been doing it all along in topic 9, which is by factoring, finding the LCD, and multiplying every single term by the LCD, which will help us eliminate the denominators, and that way we don't have fractions anymore, and then we have an easy equation to solve. So this will all make sense once we start doing some examples. So let's get started with example number 1. Okay, so let's take a look at what we have. X over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. So notice that we have a rational equation here because of the equal sign. Okay, so this is a rational equation, not an expression. And it's an equation because of the equal sign. Okay, so pretty straightforward. The things that we've been working with have been rational expressions because we only had this first part without the equals. Okay, so now what we're trying to do is we're looking for the x. So we're looking for the x value that'll make the left side and the right side equal to each other. Okay, so what makes this a little bit harder than what we're used to is the fact that there are variables in the numerators, there are variables in the denominators, there's x's everywhere, and it's even harder to solve because we have fractions. So our goal here is to eliminate the fractions. Okay? So we'll get started with the usual, which is by factoring. Okay, so let's factor first. So the first fraction has nothing that can be factored. The second fraction has nothing that can be factored. The third fraction does though. We have an x squared minus 9, which is the difference of two squares. So by now you should know that this is going to get factored to x minus 3, x plus 3. Okay, very good. So we have factored first. Now we're going to find our LCD. I'll do that on the side. Okay, so again, nothing new here. We just need to look at our denominators. So I have an x minus 3 here. I have an x minus 3 here. So I need an x minus 3, and that gets written once here and here. I also have an x plus 3. Okay, so I need that as well. So my LCD is x minus 3 times x plus 3. Okay, good. Now the third step is to take every single term and multiply it by the LCD. Now what that's going to do, hopefully, if you do this correctly, if you have the correct LCD, what that should do is help you eliminate every single denominator. Okay, so watch. So it's gonna look kind of complicated, but the end result is gonna be pretty easy to solve. So here's my first fraction. I'm gonna try to write small because I'm gonna need a lot of space. What I'm gonna do is I'm gonna leave space after each fraction. You'll see why in a second. And I really like doing it this way because it's a nice setup that will help you do this. And I would recommend you do it the way I'm doing it. Okay, so as usual, if my LCD is x minus 3 times x plus 3, I could put that over 1. And now I need to multiply every single piece by my LCD. Okay, so I'm going to need some more space, so I'm going to make myself more space. Okay, extend the page. All right, here we go. Actually, I don't think I left enough space between these. Okay. All right, I'm gonna take the red color now, just so you could see what I'm doing. So I'm multiplying by my LCD over 1, and I'm gonna multiply my second fraction by my LCD over 1, and I'm gonna multiply the third fraction, so even the other side needs to be multiplied by the LCD. And the reason that we're allowed to do this is because this is an equation, right? And we're multiplying each piece by the same thing. So we're keeping it balanced. So we're allowed to do this because we're keeping our equation balanced by multiplying every single part by the LCD. Okay, now watch what happens here. The x minus 3 will cancel with the x minus 3 in the first piece. In the second piece, the x plus 3 will cancel with the x plus 3 on top. And in the third piece, everything on the bottom cancels. All right, so hopefully you see where I'm going with this. So let's see what happens here. So from the first piece, I have x times x plus 3, but that means I have to distribute, of course, right? So x times x is x squared, x times 3 is 3x. Very good. That's all I get from my first part. Notice I don't have a denominator anymore. Technically, my denominator is 1, but we don't need to put that. Okay, very good. How about over here? Well, over here I have x times x minus 3. So let's just distribute. Again, x times x is x squared. And then x times negative 3 is negative 3x. Very good. And look at that. On the right side, everything canceled. So I only have 2 over 1, which is just 2. Okay, let's take a look at this. What just happened here? If you notice, let's compare this with what we had in the beginning. Very big difference, right? So what we started out with was this complicated equation that had x's in the numerator, x's in the denominator. It was really hard to solve for x here. And after I was done with my process, I have a regular equation. Actually, this is going to become even easier to solve because I'm going to combine like terms. So x squared and x squared is going to give me 2x squared. And then hopefully you notice that 3x and negative 3x are going to cancel. So then I'm left with 2x squared equals 2, right? So I'm going to divide by 2. And then so that's going to give me x squared equals 1. All right, well, how do I solve for x? I'm going to take the square root of both sides. So x equals square root of 1. Remember, when we take the square root of anything, we need to consider the plus or minus. So my two values, my two solutions are x equals 1 and x equals negative 1. Okay, now I want you guys to pay attention because we're technically not done. Okay, so I'm going to type a note for you guys. So very important. After solving a rational equation, you must check every solution. to make sure it is not an extraneous solution. Okay, and you might be wondering, what does it mean for something to be an extraneous solution? So if you notice, the word extraneous has the word extra in it. So an extraneous solution is basically an extra solution that you get that might not actually work. Okay, so let's check these answers really quick. It's annoying because it does take some time, but I want to show you what the checking process looks like. So let's check. You know what? I'll just check one of them just to make my point, but you should be checking all the solutions. Okay, so let's check x equals 1. Now, just to save some time, I'm going to copy and paste our original problem. Here's our original problem. And so what you want to do to check your solution is to literally take your solution and plug it in. So here I'm going to have 1 over 1 minus 3. Let me just... So I'm plugging in 1 for every x. 1 over 1 plus 3 equals 2 over 1 squared minus 9. So this is going to be 1 over 1 minus 3 is negative 2 plus 1 over 4. Is that equal to 2 over 1 minus 9? So what is that? 1 minus 9 is negative 8. Okay, let me keep going. So yeah, this is annoying because this is fractions. Negative 1/2 plus 1/4 equals negative 1 over 4. Okay, so let's see. Negative 1/2 is the same thing as negative 2 over 4 plus 1/4. Is that the same as negative 1/4? Well, sorry, negative 2/4 plus 1, so that's negative 2 plus 1. So that's negative 1/4. Is that equal to negative 1/4? Are those two equal? Yes, they are. So this solution checks out, okay? And if you check x equals negative 1, it checks out as well, because I did this problem already, but you should check it also. But I'm going to skip that part. If you want to try that part and plug in negative 1, go right ahead. Now, the good news is I have a quicker way for you guys to check, and that's by graphing, okay? So I was going to do this later, but we might as well do it now. So what you can do to check your solutions is the following. What you can do is graph each side of the equation as an equation in Desmos and see where the two graphs intersect. So let me show you what I mean by that. So I'm going to type in the left side into... So I'm using Desmos, a graphing calculator, which is free and available for anyone to use, but obviously if you have a graphing calculator, feel free to use that as well. So all I'm going to do is type in both sides of the equations as two separate equations. So I'm going to do y equals x over x minus 3, x over x plus 3. Okay, so this is my graph. It looks a little bit weird. Very interesting. And I'm gonna graph the right side as its own equation, because I'm trying to see where these two equations are equal, which means where are they intersecting? And that's purple. So take a look. Okay, so if you notice, these two spots is where they intersect, and if you notice, the x values of these two spots are 1 and negative 1, which is what we got when we solved this problem. We got 1 and negative 1, and then here's the graph. Where they intersect, the green and the purple, are 1 and negative 1. So this is a much quicker way to check your answer. Again, how I did this is... Take a look. This left side, I graphed it as its own graph. The right side, I graphed it as its own graph. And so in order to see where these two are equal, I just have to look for literally where they intersect, where they touch on the graph. Okay? All right, let's do example 2. Guys, if I'm moving too fast, you can always pause me, rewind, listen to this as many times as you want. I know these are tough, so just take your time with them, okay? But I move kind of fast because I don't want these videos to be like an hour long, all right? Next example. Okay, so here's example 2. By the way, I don't have too many examples because like I said, I don't want this video to be too long, but this is a really important topic, okay? So the first thing we're going to do, so again, notice this is an equation because of the equal sign. So we have to solve for x. So remember, we're looking for the value or values of x that would make the two sides equal. Okay, so what we're going to do is factor first. So maybe I should start writing out the steps for you guys. So I would say step 1 would be to factor. Okay, so let's do that. X, go back to black. Okay, x minus 1 over, now we need to factor this. This is a quadratic, so x and x, two numbers that multiply to 2 add to 3, easy, it's 2 and 1. Okay, very good. Second fraction, I don't have to do anything to it. And third fraction is fine. All right, step 2, what is step 2? Step 2, find LCD, right? Okay. Let's see, LCD. So, all right, so x plus 2, both of these fractions have it, so let's write it once. And then x plus 1, both of these fractions have it, so let's write that once. Okay, so here's our LCD. So that's step 2. Step 3. Step 3 is to multiply each fraction by LCD, right? Okay, let's bring our original back. Sorry, not our original, the factored form. Oops. Hold on. I'll just write it. Okay. So again, here's what I'm gonna do, guys. I'm gonna leave space between each fraction. So x minus 1 over x plus 2, x plus 1 times something plus 2x over x plus 2 times, I'm gonna need more space here. I'll do that. Leave space here equals, what did I have here? X minus 1 over x plus 1. X minus 1 over x plus 1. Okay, again, I left space because I need to multiply by the LCD. I could put it over 1. So here's my LCD. I'm multiplying each piece by my LCD. Okay, here x plus 2 times x plus 1 over 1. And then here x plus 2 times x plus 1 over 1. Very good. So see what I did? I took each piece, multiplied it by the LCD. So here's my second fraction times my LCD, my third fraction times my LCD. Remember, we're trying to keep things balanced. So if we take each part and we multiply by the same thing, that's allowed because we're not messing up the balance of the equation. All right, let's cancel stuff out. So these will cancel, right? And then x plus 1 will cancel with x plus 1. The x plus 2 here will cancel with this x plus 2. The x plus 1 here will cancel with the x plus 1. And remember, guys, if you do this right, you will cancel all the denominators. That's the whole point. All right, well, this problem is not bad at all because take a look here. We have x minus 1 times these both canceled, so it's just x minus 1. Plus, how about here? We've got 2x times x plus 1, so we have to actually distribute. So 2x times x is 2x squared. 2x times 1 is 2x equals, all right, last piece. All right, so we have an x minus 1 here, that's a quantity, times an x plus 2. So I'm going to write that out just so you could see it, which means it's going to take a little bit more work because we have to FOIL, right? Quote unquote FOIL. So if you want to put a little note for yourself, FOIL. All right, so let's FOIL this. First, x times x is x squared. Outer, x times 2 is 2x. Inner, negative 1 times x is negative x. And last, negative 1 times 2 is negative 2. I'm going to combine like terms here in one shot. 2x minus x is 1x. And then the minus 2. Okay, the right side is good. Let's see the left side. Okay, so I'm going to put things in order. This is a 2x squared. Then we have an x plus 2x, so that's going to give us 3x. Then a minus 1. Okay, so here's our equation. Okay, very nice. There are no fractions, so that's good. That was our goal. But you can kind of see it's gonna be a quadratic. So because it's a quadratic and we need to solve, remember we're looking for x, we're gonna get everything on one side because we're gonna have to factor this quadratic. Okay, so let's do that. Minus x squared minus x squared. These will cancel, so this is gonna be 1x squared, or just x squared, plus 3x minus 1 equals x minus 2. Okay, I'm just trying to get everything from the right to the left. So subtract x. These will cancel, so 1x squared. 3x minus x is 2x. Minus 1 equals negative 2. Okay, almost there. So now let's add the 2. Oops. Okay, good enough. Okay, these will cancel. We'll be left with 0 on the right side. So this is going to be x squared plus 2x plus 1. Okay, notice this is a quadratic, which means we have to factor and then solve. Okay, not the best handwriting, but it's all right. Okay, we gotta factor this. Hopefully it's an easy one, and it looks like it is. So let's see. Oh, I don't know what's happening. Okay. Two numbers that multiply to 1 and add to 2 is just 1 and 1, right? Okay, so then, hopefully you guys remember all of this. We have two quantities being multiplied to give us 0. So the zero product property says that we could set each piece equal to 0 and solve, but we don't really need to solve this twice because each piece, they're exactly the same. So if I solve for x, I get x equals negative 1 twice. Now, do I have to list that twice? No. Okay, so this is our answer, but we have to check. Okay, so we can check by plugging back in, or we can graph. Okay, let's see. Oh, actually, I actually should have pointed something out from before. We do have restrictions too, right? So what could x not be here? Let's see. X cannot be negative 2. X cannot be negative 1. And x cannot be, that's it, right? So it turns out that our answer is one of our restrictions. Because if x was negative 1, one of our denominators is going to be 0, which is going to give us an undefined fraction. So I'm going to write that down for you. Because x equals -1 is a restriction, here, let's write it here. And I need more space. So, because x equals -1 is a restriction, x equals -1 cannot be our solution, which means it is an extraneous solution and does not count. Okay, which means that there is no solution here. So the answer, the final answer, is no solution. Okay? All right. That was example 2. There was a lot going on. If I go back to example 1 for a second, I just want to point out that the answers we got from example 1, 1 and -1, they were not restrictions, and we should have listed our restrictions. That was my mistake. But what are the restrictions here? The restrictions are x cannot be 3 and -3. Okay? But either way, whether or not your final answer is a restriction, you should also check by plugging it back in. Okay? And this one, I think it would have been pretty easy actually to check, because if x was -1, -1 plus 1 here, this fraction would have had a 0 in the denominator. Because if this was -1 plus 1, that's 0. So then you would have been dividing by 0, which would have given you an undefined fraction and an error on a calculator. So that's why our final answer here did not work out. Okay, let's go to example 3. So for example 3, I have a little note. It says you can use Desmos or a graphing calculator to check the solutions of a rational equation. I actually talked about that in the beginning when we did example 1. I was going to wait till example 3 to bring it up, but we talked about that already. So I do recommend you use the graphing calculator, not to give you answers because you have to show your work anyway, but to just check your answers and make sure you're on the right track. Okay, and we'll do it with this one just so we can practice some more with Desmos. Okay, so so for this one, what I'm gonna do is we have two fractions, but the right side is just a 1. So sometimes that confuses people. So I'm actually just gonna change the 1 to 1/1. Okay, just because it helps people see it as a fraction. So the method, it's the same steps, even if this third fraction isn't really a fraction. But actually, we don't have much to factor. If you look at what we have, x plus 2 and x minus 2, we can't factor anything. So let's skip to step 2, which is your LCD. So I have an x plus 2, I have an x minus 2, and I have a 1. Oh, sorry. That is not a 2. X plus 2, x minus 2, and I have a 1. Technically, I could put a 1 here, but it's really not necessary, okay? Because it's not going to affect our multiplication, okay? So now we're going to take our LCD and multiply each piece by the LCD. So just to save time, copy that, put it here. Oh, sorry, hold on. Okay. Let's copy that, paste it, and I'm gonna give myself space. No, that's not what I want to do. Okay, it's not letting me. Oop. Sorry, guys. I thought I was getting the hang of it, but it's gonna. Sometimes it does weird things. Okay, so here's my first fraction. I'm gonna leave some space. Wrong color. Okay. Here's my second fraction. I'm going to leave some space, and then here's my last fraction. All right, let's multiply by our LCD. Again, if you want, put it over 1. I need more room. Move this down. Okay. X plus 2, x minus 2 over 1 is our LCD. So x plus 2, x minus 2 over 1. So then multiply this by x plus 2, x minus 2 over 1. And then same thing here. X plus 2, x minus 2 over 1. Okay, let's cross things out. So the x plus 2 with the x plus 2, the x minus 2 with the x minus 2. And here, there's really nothing to cross out because here there was no denominator anyway to begin with. Okay, so let's see what we have. Here, in the first fraction, we just have to distribute our 2. So 2 times x is 2x. 2 times negative 2 is negative 4. Plus, okay, here, we also have to distribute our x. X times x is x squared. X times 2 is 2x. Very good. And the last fraction is just x plus 2 times x minus 2, which again, hopefully you noticed you're going to have to FOIL this. Okay, so x times x is x squared. Those are our first terms. Outer x times negative 2 is negative 2x. Inner 2 times x is positive 2x. And last, 2 times negative 2 is negative 4. Okay, rewriting this left side. And you could start simplifying at this point. So let's see. On the left side, I've got, oops, no, these are not going to cancel. 2x plus 2x is 4x. So this is going to be x squared, I'm just putting it in the right order, plus 4x minus 4 equals, and then here, these will actually cancel. Negative 2x plus 2x will cancel. So here I have x squared minus 4. Okay, let's get everything on the same side, but let's see what happens if I subtract the x squared. These will cancel, but so will these. Okay, so we actually don't have a quadratic in this scenario. So because we don't have a quadratic, we can just solve for x by getting x by itself. So I'm going to add 4 to both sides. These will cancel, so 4x equals 0, which means that if I divide by 4, x equals 0. Okay, so before we do anything, I want to go back up and write our restrictions and make sure that that's not a restriction. So let's see. X cannot be negative 2, and it looks like 2 from here, right? Guys, if you're having trouble coming up with the restriction, just take every denominator and set it equal to 0 and solve. So here, what would make x plus 2 0? That would be if x was negative 2. And here, what would make x minus 2 equal to 0? That's if x was 2. So this is good so far because our solution, I hate when it zooms in. Anyway, our solution is not a restriction. So that's good news, but that still doesn't mean that 0 can't be an extraneous solution. We actually have to check if this works. Let's check by plugging in. So check solution by plugging back in, okay? Just to practice checking again. So let's check. So we're checking the solution x equals 0, and then our original was the following. It was 2 over x plus 2 plus x over x minus 2 equals 1. Okay, so we're checking if both sides are going to be equal. So this is going to be 2 over 0 plus 2 plus 0 over 0 minus 2, is that equal to 1? Let's see. So this is 2 over 0 plus 2 is 2 plus 0 over negative 2, is that equal to 1? 2 over 2 is 1 plus 0 divided by negative 2. 0 divided by anything is always 0. Is that equal to 1? And as you can see, 1 plus 0 is 1. That is equal to 1. So both sides are equal to 1, which means that this solution works, which means that x equals 0 is truly a solution. It's not an extraneous solution. And then I'm going to show you how to check by graphing. So if we go to Desmos, okay, go back to our original. Let me delete these. It's getting a little messy. Okay. Delete these two that I had. Okay. So again, guys, just graph each side. So the left side is y equals 2 over x plus 2 plus x over x minus 2. So that's the left side. And for mine, it's black. It's in black. This is the graph. And then the right side is just y equals, it's just a 1. So you could just graph y equals 1. Okay? So now look at these two, the black and the red. Where do they cross? Well, it looks like they're crossing right over here. And what x value does this point have? It has an x of 0. And what was our solution? Our solution was x equals 0. So it looks like these two match. All right? So when you graph to check your answer, graph both sides as two separate equations like I did here. So here's 2 over x plus 2 plus x over x minus 2. That's the left side. And the right side here was just 1. So y equals 1. And then check where they literally intersect on the graph. So the black is one equation. The red is another equation. Where are they crossing? The only point I see is here. And what x value is that? That's 0. Because remember, we are, after all, solving for x. Okay? So hopefully this video wasn't too long. Again, this stuff is difficult, so it does take a lot of practice, guys. Take your time, write down these notes, and rewind and pause the video as much as you need to understand what's going on. Okay?